Requirement elicitation is a very hard problem. And the main reason for this is because customers and users are not always good at describing what they actually want or they even need. Software engineers, in general, are not always good at understanding someone else concerned. Keep in mind that in certain application domains, software engineers and customers, they do have completely different background, in addition to different terminology. That makes requirements elicitation a hard task. A major concern that makes even the process of eliciting requirements harder is that requirements change over time. So if you collect requirements at time t, and then the requirements would change at time t1, all the requirements that have been collected at time t need to be adjusted at time t1. So if you collected those requirements and you did not update the requirements at different time frame before you start your design, then the requirement elicitation was not done in a high quality approach. So that make it a hard process. Different techniques that can be used for eliciting requirements, including brainstorming, in which we do a lot of meetings to trigger different questions. We can also do interviews in which we ask specific questions, in particular about the boundaries, exceptions, anticipated changes, vision of the future, and alternatives solutions to the problem. Also, we could perform task observations in which we can observe users at work. We can even obtain information that are not told by customers. In other words, they have forgotten to tell us because they think it was not important or they didn't even understand the implications of those um, information. We can use the use cases and scenario analysis which include all the use cases and various scenarios in the system component to gather requirements. Finally, prototyping questionnaires are another alternative techniques to collect and elicitate requirements. The third phase is the requirement analysis phase in the requirement analysis and specification process. Sometimes I would prefer using calling it phase, or you could call it activity. The commonly used word is activity, but it's okay if you're going to use the word phase for it because we start by inception, following by elicitation, and then analysis. Analysis, requirement analysis is the process of studying and analyzing the needs of stakeholders, whether they are customers or users, in viewing of coming up a solution. So we try in this phase to analyze the requirements to provide a better understanding of the needs of the stakeholders so we can come up with a solution. The solution that we could develop could actually involve new organization of the workflow in the company, the new system, or the system to be, which we can call it solution domain, which would be used in the existing or even the modified workflow. Also, in the solution that we're trying to develop might include a new software to be developed, which is to run within the existing computer system or even involving modified in traditional hardware. The main objectives of the requirement analysis phase include detecting and resolving conflicts between requirements, and this could be done through negotiation. Also, it includes a discovery of the boundaries of the system or even the software and how it must interact with the environment. It Another objective of the requirement analysis phase, it elaborate the system requirement. So we look into the requirements on the system level in order for us to derive software requirements. I will talk later about different type of requirements, including system requirements, user requirements, software requirements. But in general, one of the main objectives for the requirement analysis phase is to elaborate on the system requirements or focus on the system requirements in order to derive the software requirements. The fourth activity in the software requirement analysis phase, including requirement specifications. In this activity in particular, we look into the definition of the behavior of the new system that we're trying to develop. we are in the solution domain, such that it will produce the required effect of the given problem domain. So we start by a problem domain, and then we would like to go into a solution domain after the analysis phase. In the requirement specification phase, we are still in the solution domain phase, but we are monitoring the behavior of the new system. The outcome of the requirement specification phase is a document. We call this document the software requirement specification document, the SRS document. And this document actually it describes each of the essential requirements in the system, including functional requirements, performance requirements, design constraints, and even quality attributes for the software itself and for the external interfaces. In the requirement specification phase, we are talking about a detailed description of the software to be developed. We know that it may include a set of use cases, so we can still use the notion of use cases over here, or the modeling techniques using use cases that can describe the user interactions that the software must provide. Software requirement specification establishes the basis for an agreement between the customers and either the contractors or supplier on what the product is to do, as well as what is not expected to do. Software requirement specification permits a grade assessment of the requirements before design can begin, and actually it reduces later redesign, because once you collect the requirements in the elicitation phase and then provide a deep analysis of the requirements, you came up with an initial draft of the requirements. No matter what the requirements are, you have documented this in the software requirement document, which include a full description of the system to be developed. This document has to be designed in a way it provide an assessment of the requirements, which means it has to be in a shape that it's really close to what the customer need. So we, in order to avoid a redesign of the software again, which helps, of course, the developers in the design phase to save more time. And of course, we would reduce the cost of defects removal at later stage, because we have provided a precise and concise and accurate with high quality requirements after the requirement analysis and specification phase, which is done through the requirement validation and verification phase or activity. Both validation and verification, they help in ensuring that we are delivering what the customer wants. You talk to the customers, you have collected requirements, and then you analyze the requirements, you provide more specification and description of what the customer want. You would like to ensure that there is no ambiguity in the requirements. You would like to ensure that it's complete, it's correct, it's accurate. This will be done in the requirement validation and verification activity or phase in the requirement analysis and specification process. Keep in mind that validating and verifying requirements should be performed at every stage during the process. What is the difference between validation versus verification? In validation, we check that the right product is being built. And then we have to go back to the stakeholders for discussion in interviewing or meetings to be sure that we are building the right product. Verification is all about checking that the product is actually being built right. In the design phase, we refer back to the specification of the system or the software requirement specification that we have developed. And during the requirement engineering process in total, mainly we are checking on consistency between the different requirements, and we try to detect conflicts. All of these are conducted in the requirement validation and verification activity. Techniques that are used during requirement engineering for validation and verification, including simple checks over the requirements. You could do formal review on the requirements. You could even perform logical analysis. You could do prototyping. You could do design of functional tests on the requirements. And finally, you could develop user manual. After we have tested the requirements for any conflicts or inconsistency, or even any defects that we may expect that impact the quality of the requirements, we have now requirements ready to go to the design phase. However, we need to um, cope with the changes to the requirements. This is done through the requirement management activity. And when you ask yourself why requirement may change, it's because the problem process itself has a changed, or even the technology has a change, and management to the requirement would provide better understanding of the problem itself. So keep in mind that tracing the changes in the requirement is very important in order to guarantee effective requirement management. Now, we do have requirements specification document that should be sent later on to the next phase of the process development cycle, which is the design phase. So we have different set of requirements. In particular, in general, we look for the SRS document. However, we could have along the way a different set of documents that are generated either on the elicitation phase or even in the analysis phase or even in the specification phase. So at the end of the requirement analysis and specification, we do have SRS, but we could have vision and scope document that is obtained after the inception phase. We could have elicitation notes. These are different type of documents that we can see it across the requirement analysis and specification phase. Elicitation notes, which refer to those raw requirements that are obtained through elicitation. Often, like those requirements are completely unstructured. We don't have any structure, shape, or design for those elicitation notes. They are still incomplete and they are inconsistent. When we are in the problem domain, we are collecting requirements documents as well. And if we are talking about the system requirements, so we do generate system requirements document. And we also have different type of requirements, which is software requirements. So we generate software requirement documents. The software requirements are normally part of the system requirements. We will talk about this later, but for now, we say that along the way, we do have different set of requirements. It ends up with the SRS, but in each activity in the requirement engineering phase, or the requirement analysis and specification phase, we do have vision and scope document. We could have elicitation notes. We could even collect documents about the system requirements, documents about the software requirements. What type of documents, of requirement documents we can obtain in the entire requirement engineering process? We have actually two extremes. The first one is informal outline of the requirements, and this could be done using few paragraphs or just simple diagrams. We call this requirements definition. So requirement definition is just informal outline of the requirements. And if we actually generate a long list of specifications that contain thousands and thousands of pages that would describe the requirements in details, this is called requirement specification, which is the final output of the requirement engineering process or the requirement analysis and specification phase in the software development cycle. Requirement documents for large systems, keep in mind that nowadays most of the systems are large and complex. So in order for the developers to have better understanding of those requirements, they are designed or they are arranged in hierarchy. As you can see in this figure, we do have hierarchy of requirements. So for example, in subsystem one, we do have the requirements for the system in total, and then we have divided into requirements for each subsystem of this system. We build a hierarchy of all the requirements, whether they depend on each other or they are independent, what type of requirements we might have. We do the same for system two, for example. In simplicity, I would like you to look to the hierarchy as a structured way of representing large um, number of pages of requirements by dividing them into hierarchy of different requirements for each subcomponent or subsystem of the entire system. What are the challenges in the requirements process? We could have lack of right expertise, whether it's on the software engineer level or even the domain experts level. Also, initial ideas are often incomplete. Like you try to collect as much as you can, but keep in mind that most of the information collected initially are incomplete. Also, it's optimistic. They assume that everything is easy to be developed or designed, which is not the case. Also, it's firmly established in the minds of the people that leading to the acquisition process that it's an easy task, which is not the case. Difficulty of using complex tools and diverse methods associated with the requirements makes the requirement process challengeable because it may negate the anticipated benefits of the complete and actual the detailed approach of collecting and analyzing the requirements. Let's look to some statistics provided from the National Institute of Standards and Technology. They have published a comprehensive report of 309 pages that are actually very interesting on project statistics and experience based on data collected from large number of software projects. What we can see here that 70% of defects are actually in the specification phase. 30% of the defects are introduced later in the technical solution process. Just only 5% of the specification um, in adequacy are correct, which make it like really hard because that's a very small number. So 95% are detected later in the project or even after delivery, where the cost for correction is average at this time. If you wait until you make the corrections, can you see the number here? The cost for correction is 20 times higher as compared to if the correction was directly during the specification efforts, because we have 70% of the defects are happening in the specification phase. It was included in the report that extensive testing is essential. However, testing detects the dominating specification errors, well, comes later in the process. There are different categories for requirements. During a system development project, requirements will describe either the business needs, and then we call it business requirements, or what the user need to do, we call it user requirements, or what the software should do, we call it functional requirements. And finally, the list of the characteristics that the system should actually have, like the properties of the system that should actually have, we call this non-functional requirements. What are business requirements? Business requirements are all about what must be delivered to provide a value for the business problem or the software that would be developed. For example, we would like to develop a system that will increase the market share or even shorten the order processing time, to reduce the customer service cost, or even to lower the inventory spoilage. And it might improve the responsiveness to customer service requests, and even it could provide access to provide account access to mobile customers. These are different values by which we develop a system when we collect information about what must be delivered to gain a value or to provide a value, like those examples, we call this business requirements. When the system development project is complete, that means the success will be measured by evaluating whether the stated business requirements, so we have to state those requirements clearly, have been actually achieved or not. So we say the project is complete. When the project is complete, the success will be measured by just mapping what we have described or indicated in the business requirement compared to what have been actually achieved. So what do we see in a business requirement? We see what must be delivered to achieve the goal. So or the value, or to have a value, like some of those might be increasing revenue, some of those might reducing processing time, some of those might provide customer satisfaction. So these are the values that the system must be developed to achieve those goals. So the second type of requirements is called user requirements. User requirements are those requirements, so they are, keep in mind requirements at the end just text. So we just keep writing statements like about what the user need, what the system should do, what are the function of the system, what are the main shape of the system, what are the main properties or characteristic of the system. All of them are just like text. So when you start writing text, simple description about what the user expects the system to be able to perform, we call this user requirements. User requirements, they actually describe those tasks that the user perform as an integral part of the business operation, including but not limited to determining available credit, lookup for account balances. These are examples. Scheduling a client appointment, place a new customer order, or even reorder inventory. So the user will state clearly what they are expecting the system to be able to. These are the user requirements. The third type of requirements is called functional requirements. Functional requirements are those requirements that actually defining the functionality of the system under development. So when you talk about anything that is related to the function of the system, or like what the system would do, this is when we refer to it as a functional requirement. So functional requirement, it defines how the system will support the user requirements. A functional requirement relates directly to a process in which the system has to perform. Let's have a look to those different examples of functional requirements. So functional requirements are those requirements that are aligned to what the system would do to satisfy the user need. Examples like what input the system should accept. This is a functional requirements because we're talking about the functionality of the system in terms of the input. We could even talk about the output of the system that should produce. What data the system should store, what other system might use it, what computation the system should perform, the timing and synchronization of all the above, which include the input, output, and the data. And also we could have another example for functional requirement. We could state in the function requirement, this is a statement saying that we would like the user to be able to search either all of the initial set of the databases or just a select subset from it. So this is a functional requirement. You would like your system to provide a chance for the users to search either in the initial set or just a subset. You have indicated a requirement that is related to the system functionality to allow the users for different alternation or alternative way of searching the system. We could another example is we could state in the functional requirement that we would like the system to provide different viewers for the user to read documents in the document store, for example. We could even talk about orders. If our system is built for online purchase, every order shall be allocated a unique identifier. So you would like your system to provide a unique identifier for each order, which the user shall be able to copy to the accounted permanent storage area. This is if this statement is seen in the requirement document, we know that this is a functional requirement because it addresses system functionality. We are referring to the system function that will allow orders to be allocated with a unique identifier. Like let's read this statement and see if it's really addressed the functionality of the system. If you add a new entry for an appointment type, including patient name, which might read up to 30 alpha characters and duration in the unit of minutes, you are stating a statement about the functionality of the system to allow a new entry. So you would like your system, when you click on a button, this button will generate a new entry. So the system, when it's developed, I would like the system to allow a creation of a new entry This is function of the system. So this statement is a function requirement. Like if another example, let's read this requirement: modify the duration in an existing entry. So we would like the system to allow a modification to the duration in an existing component or entry in the overall platform. This is a function of the system. We are not talking about user requirement right now. We are not talking about business requirements, and we are not even talking about characteristics of the system. We are talking about a function that the system would do. So this is why we call it functional requirements. The last type of requirements is called non-functional requirements. Non-functional requirement, of course, is this type of requirements that are not functional. So they are not related to functionality of the system. They just focus on important behavior or properties or characteristics. Sometimes we call it quality attributes that the system must have, including, for example, performance and scalability. Non-functional requirements, they are very important because if we design a system that at the end we did not meet those non-functional requirements, so the system is useless. Non-functional requirements may be very difficult to state precisely, especially at the beginning in the inception phase, and imprecise requirements may actually be difficult to verify. So non-functional requirements are those requirements that would need a lot of attention, either on the elicitation phase or even the analysis and specification. And it also it would need a lot of time to be verified. As I said before, sometimes we call it quality requirements. In different textbooks, we might refer to it as quality of service requirements, extra functional requirements. Many would be discovered during the conversation with the user in the analysis phase. However, not all of it would be discovered. These requirements don't describe the business process or information, but they are very important in understanding what the final system should be look like. So we are not talking about business requirements, nor user requirements, or even functionality of the system, but we are talking about properties, characteristics of the system. And all requirements, whether they are functional requirements or non-functional requirements, should be actually verified. So we have to perform some kind of test or an inspection or even auditing to guarantee that those requirements are verifiable. Let's look to different types of non-functional requirements. So keep in mind, non-functional requirements are not related to the system functionality, is related to the system characteristics. Some of the characteristics that we could use it to describe the system to be developed, including performance requirements, design constraints, sometimes we call it design requirements or commercial constraints. Performance requirements, though, are those requirements that actually used to reflect and characterize the system properties, including expected performance, the usability of the system, efficiency of the system, reliability, maintainability, reusability, and even security requirements. Example, which I will define later, of performance requirements, including response time, throughput, resource usage, reliability, availability, recover from failure, and also allowances for maintainability, enhancement, and reusability. What are design constraints? Design constraints are those requirements that belong to the category that constrain the environment or even the technology of the system. Examples of design constraints including constraints on the platform. What are the main requirements? What are the main operating system to be used and the devices to be involved? We could have design constraints even on the technology to be used. What programming language will be used? Which database we will store our data in? So when we talk about databases, language, technology, or even platforms, we refer to design constraints. Third type of constraints, which is another type of non-functional requirements, is commercial requirements. These are categories that constrain the project plan, and the development methods. Keep in mind that it's related to cost and delivery dates, and we have to clearly state the commercial constraints in a contract or project plan. As I said before, we have different type of non-functional requirements, whether they are performance requirements, um, um, whether or before, why not my screen change? Whether they are performance requirements or design requirements or commercial requirements. Some of them are important to the users. Some of them are important to the developer. Performance is important from the user perspective, security, usability, compatibility, accessibility, even reliability and flexibility, interpretability. All of these non-functional requirements are really important to the users. What is really important to the developers in the design phase include the maintainability of the requirements, portability of the requirements, reusability of the requirements, and testability of the requirements. Let's define some of these non-functional requirement types. When we refer to usability, we are referring to the ease with which a user could actually learn to cooperate, prepare the inputs for, and even interpret the output of a system. This is mainly related to the user interface, the number of the nested level in a given menu, what are the color schemes that would be used, what if there is an online help or not, and the level of documentation. This is all about the usability of the requirements. When we refer to dependability, we are referring to the property of the system such that reliance can justifiably be placed on the service it delivers. When we talk about dependability, we are referring to reliability and robustness and safety. What is reliability? Reliability is the ability of the system to actually perform the required functions under a stated condition. This is for a specific period of time. Reliability means acceptable mean time of failure, as an example, the ability to detect the specific faults, or even withstand with specific security attacks. Robustness, on the other hand, is the degree to which a system can function correctly in the presence of invalid inputs or stressful environment conditions. What is the safety? Safety is a measure of absence of catastrophic consequences to the environment. All of these are types of non-functional requirements that must be clearly stated in the elicitation phase. If not all collected in the requirement specification phase, we add more of non-functional requirements that must be clearly defined and included and tested and validated. So we might see some statements in the requirement document that is addressing the dependability of the software. We might see some requirements that addresses the robustness of the software. We might even see some requirements that are talking about the safety of the software. We might see some requirements that are talking about the robustness of the software. So any words that is related to the characteristics or properties of the system is denoted as non-functional requirement, and it has to be clearly stated in the specification document. According to Somerville classification, non-functional requirements could be classified to three types: either product requirements, organizational requirements, or even external requirements. Product requirements could be of any type as usability requirements, efficiency requirement, reliability requirements, and portability requirements. For efficiency requirement, we might have performance requirements as well as space requirements. When it comes to organizational requirement, we are referring to delivery requirements, the due date of delivery, as well as the implementation requirements. On the other hand, external requirements is composed of either portability requirements, might be ethical requirements, or might be legislative requirements. When it comes to legislative requirements, we are talking about customer privacy and safety requirements. Another non-functional requirements that we see a lot in different requirement documents, including performance measures that define those quantifiable attributes of the system, like the response time of the system, the throughput of the system, availability of the system, and even the accuracy of the system. What is a response time? A response time means how quickly the system reacts to the user input. What is the throughput of a system? It's how much work the system can accomplish within a specific amount of time. When it comes to the definition of availability of a system, it means the degree to which a system is actually operational and accessible when required for usage. An example, when we have a quantified number or a measure like 0.998, that means in every 100 time units, the system is likely available for 998 units. That's when we use the word availability. Accuracy of a system means the magnitude of error. The less error we have, the high accuracy we could retrieve. Supportability is another non-functional requirement, which means those requirements that are concerned with the ease of changes to the system after deployment, including how the system could adapt to the changes, whether the system could be maintainable or not. Adaptability of a system refers to the ability to change the system at some point to deal with any additional application domain concept when new concepts or new application domains are added. Maintainability of a system refers to the ability to change the system to deal with the new technology or even to fix any current defects. Let me show you some examples of non-functional requirements. Like on the product level, we say like we do have some product requirements that are stated in the requirement document. We know for sure that they are non-functional because they are not describing neither a user requirement or a business requirement or even a functional requirement. So in the requirement document, let's look to this statement. It says the product should be readily portable. So we talk about portability to the Linux operating system. Portability is a non-functional requirement. So the entire statement, portability is a non-functional property or characteristic of a system. So the entire statement is a non-functional requirement. Let's look to the next statement. The product should be easy to use with with only one hand. We are talking about the usability property. So this is a non-functional requirement. The next statement, the product should be used with poor lighting conditions and the users will wear gloves, for example. We're talking about the feasibility of the product. So this is another property of the system. So this is um, a non-functional requirement. Let's look to the next one. We are talking about a product that can identify an aircraft within 0.25 seconds. So this is the response time of a system. So the response time is a characteristic or property, which is not a functional of the system at all. It's just a property or characteristic. So this statement is a non-functional requirement. Another example of non-functional requirement, including like process requirement, if we are talking about the system process itself, we might even have some examples related to security requirements. Let's look to this statement and see if it's really a non-functional requirement or not. The system shall not disclose any personal information. So this about privacy about customers apart from the name or even reference number to the operation of the system. So it looks like the system is talking about privacy, or even later for complex applications, we might talk about safety of a system. Look, for me, this looks like a security requirement. A security requirement is not a functional requirement, it is a non-functional requirement. Uh, let's classify now the non-functional requirement based on which one are actually quantifiable. So we're going to refer to the quantitative non-functional requirements. Speed is a quantitative non-functional requirement. Example, like the process transaction per second, user and event response time, and then the refresh time taken for the screen. The size is a non-functional requirement. For example, the storage, how many bytes do we need, and the number of RAM chips. So this is a quantifiable or quantitative measure that we are using to describe certain characteristic of the system, which is a quantitative measure. Easy of use could be quantifiable using the training time and the number of help frames. Reliability could be quantifiable using the mean time to failure, the probability of unavailability, the rate of failure occurrences, and availability. Robustness of a system could be quantified using the time to start after failure, the percentage of events that are causing failures, the probability of data corruptions on failures. Using those quantitative measures, it's easy for me to quantify those non-functional requirements. Finally, portability. When we refer to portability, we could quantify this using the percentage of target-dependent statements, as well as the number of target systems. All of these are numbers, so we can use those numbers to represent the non-functional requirements. Some of these including speed, size, easy if used, reliability, robustness, and portability. This is according to the definition by Jarlett and Sommerfeld in Requirement Engineering Process and Technique textbook, which was published in 1998. How would we identify non-functional requirements? Non-functional requirements can be identified by breaking the requirements into two groups, tasks and subtasks. So we always start by functional requirements. So we identify what the system would do. And then we break this to like two or three or four or five, forever, set of functional requirement 1 and functional requirement 2. Each functional requirement will be divided into tasks like task 1, task 2, or even task 1 for functional requirement 2. And then you break those tasks and even subtasks to set of non-functional requirements. So non-functional requirement 1, non-functional requirement 2. So for task 1, we have 2 non-functional requirements. This is for task 1. For task 2, we have 3 non-functional requirements, and this is for functional requirements 1. And for functional requirement 2, we just have 1 task with 3 non-functional requirements. Let's take an example to show this idea of identification of non-functional requirement. A customer is interested in developing a software that performs 2 tasks. So we're talking now about the functionality of the system to either add product to a cart or to check out. So the statement in the requirement that says add product to a cart is a functional requirement, or check out is another functional requirement. We're gonna break this into subtasks, or like task, and then in hierarchy level we could do subtasks. So we could say we do add product to the cart without login or with login. When we would like to perform the functional requirement of checking out, we could do checkout using credit cards, or could even we have checkout using PayPal if we're interested to add another task. For logging, for adding a product to a cart without logging in, we look into the non-functional requirement related to usability and performance. When we perform the system in order to allow the addition of a product to a cart when we do an online purchase, especially for e-commerce applications, and then we assume we would like to allow this addition to the cart with login, that means we have to state clearly the security requirements, the usability requirements, and the performance requirements. All of these are still non-functional requirements. Now, look into another subtask related to functional requirement 2, which is after the fact you added items or product to the cart. Now it's time for checking out. When you check out using credit card, what are the main non-functional requirements that must be stated clearly? We're looking for security requirements, of course. You don't want anything to steal your credit card number. You're looking for PCI, which is protocol in security networks, compliances. We're looking for performance measures, performance requirements, as well as usability requirements. So as you can see here, when we meet with the customer and then they state their requirements, initially we are looking for the functional requirements. Those functional requirements will identify in general what the system would do and then we break it down into subtasks or tasks, and then subtask, and then subtask in hierarchical level. And then at the end, each subtask should be characterized or aligned with a set of non-functional requirements. Those non-functional requirements, we go back to the customers, and then we ask them for incremental elicitation. Like we say, now you would like to add a product to the cart without login. What is the performance you're looking for? Do you would like to allow only 10 seconds of additional to the cart? Would you like timeout? Like after a certain time, would like you the session to be closed. So this is more related to the performance or the throughput of the system to respond to a certain action. When you do enforce login, for example, then you go back and say, what kind of security requirements that we need to address it here in order to allow users to add any item to the cart, but they have to log in first. So non-functional requirements are extracted after the fact. You start by defining the business requirements, the user requirements, and of course the functional requirements. You try to break down the functional requirements into tasks, and then from the tasks you will retrieve the non-functional requirements, and you go back to the customer or the stakeholders and try to collect as much as you can about the non-functional requirements. So this example it shows to you exactly more detail about how you define the non-functional requirements either on one level or multiple levels. So assume we were able to break the functional requirement one into two tasks, without login and with login. And then with login, we do have three non-functional requirements. So non-functional requirement one and non-functional requirement two, and then non-functional requirement three. And then we gonna focus for now on the security. You're gonna even break it down to all the non-functional requirements related to security, including the SSL implementation, the password policy, the role-based authorization, the PCI protocol, compliances, the integrity of account, and even the data confidentiality and how the SSL implementation is implemented, maybe before or after PCI. So you can see here related to the following the PCI, or even individually at the beginning. So we identify the non-functional requirement for each task to establish a certain goal or objective at the end. And then you continue until you cannot actually decompose further. So the idea is you start by functional requirement, you break it down to tasks. Those tasks, you're gonna decompose them into non-functional requirements. And then you keep in a hierarchy level of decomposition until you retrieve all of the non-functional requirements to meet the certain goal. So the goal here for me is to achieve the development or the design of adding product to cart with certain functionality. To achieve this, what are the whole set of non-functional requirements that are needed to satisfy such functional requirement? If we compare functional requirement versus non-functional requirement, we know that functional requirements, they are talking about or they addressing product features, while non-functional requirements, they address product property. Functional requirements, they describe the actions with which the user work is concerned in terms of what the system would do, while non-functional requirements, they actually describe the experience of the user while doing the work, which is related to what kind of characteristics we could retrieve about what we are developing. In functional requirements, a function could be easily captured in a simple use case, while the non-functional requirement is a really global constraint on a software system, which might result on the development of cost and operation cost as well. Functional requirement is concerned with the functionality of the system, in which we focus on the behavior that could be analyzed by simply drawing sequence diagram, state diagrams, or state charts. However, when it comes to non-functional requirements, we are often talking about software qualities. So for functional requirements, it's easy to be modeled or analyzed using some modeling techniques, while for non-functional requirements, it's hard to be modeled. We just refer to software qualities or measures that we need to clearly address it in a specification document. Functional requirements could be easily modeled using different type of models, either like using structure-based model or object-oriented based models, including sequence diagram, use cases, state diagrams, and so on. So later on, when we're referring to modeling techniques, we focus on functional requirements. Functional requirements can be easily traced to individual set of programs. However, non-functional requirement cannot be implemented in a single module of a program. You have to divide it or decompose it into multiple layers or multiple tasks or multiple components in order for you to collect those non-functional requirements. What are the main source of requirements? It could be retrieved through discussion with all classes of stakeholders to elicit the requirements based on the individual perspective of the process and the involved stakeholders. We could collect requirements using some competitive analysis of any computing system that is actually in the marketplace. So you could like look to the current systems, and if your system is similar to current system in the marketplace, simply do some competitive analysis or like comparative analysis. We could even collect requirements using policy and procedure manuals for the business and the process at hand, such that the system interactions, mainly the constraints, could be easily identified. Another way to collect or to have a source of requirements through the marketing and customer care departments, which should not be actually overlooked. It's likely that they have data that can be easily extracted from different customer surveys, questionnaires, interviews, maybe another like social network that was able to collect customer reviews. This information could be easily extracted to develop requirements. We can also see requirements for legacy systems or like legacy systems are source of requirements. um, what can we see on those systems? We can see system manuals, we can see specifications, we can see issue logs, enhancement request. All of these are source of legacy systems that can be used for a good source for requirements. If we say we have collected those requirements with either on the function level or non-functional level, like we say it's function versus non-functional, there's a complete requirement specification characteristic or conditions that must be satisfied to guarantee that our requirements are of high quality. This refer to it as requirement characteristics include the clearness of the requirements. We are looking for clear requirements. We are looking for correct requirements that are consistent, requirements that are coherent and comprehensive, requirements that are modifiables. It's easy for me to modify the requirements if there's any changes in the environment, requirements that could be easily verifiable, or could be at least verifiable. So if you could verify it, that makes the requirement of high quality. Requirements that could be prioritized based on the application. We'd like to guarantee that there is no ambiguity in the requirements and the requirement can be easily traceable. We, most importantly, we would like to collect requirements from credible source. We don't want it to go to any unknown websites, and then if you would like to develop a system that there is existing system similar to it, but these existing system are not trustable, then the requirements that are collected from those untrustable systems, we don't consider them as a credible source. All of these are examples of requirement characteristics that we hope that we can achieve them to guarantee that the requirements that have been collected or elicited or gathered at the end is of high quality. Let's look to this example and then illustrate the idea of good quality requirements versus bad quality requirements or requirements of low quality. So let's assume we have the restaurant advisor system. And then in the requirements document, we have all of these sentences. So it states that this system will allow people to choose a restaurant in a city. Users will enter one or more of the following criteria, and then the system will search the database for suitable restaurant. What are those criteria? The user will enter food type, price range, neighborhood, size, surface type, whatever the type of the surface is. It could be fast food, cafeteria, buffet, or even full service. The smoking arrangement, like is it allowed or not, and so on. The user can also specify a desired day and time for the restaurant that they would like to book, and the number of people in their party. If they have small number of people or large number of people based on the reservation. The system will tap into the reservation database, and then for participating restaurants that are stored in the database, and only display those requirements that have available spaces. And then after entering the criteria, the user will click on search, and the system display a list of matching restaurant. For restaurants that participate in the automated reservation system, the user can click on reserve next to the selection in order to make a reservation. So this a set of requirements that are required to build a restaurant advisor system. Some of them are functional, and some of them are non-functional. But I'm not addressing functionality now or non functionality of requirements. I'm just looking for quality of requirements. I want you to point out what problems you might find in this short statement of functional requirements. The entire description, including the non-functional requirements, is not listed here to build the entire system. But this problem has both functional and non-functional. But for this just functional requirement, let's point out those problems that we might see in this short statement. We see duplication problem. Like, for example, if you review the statement again, you will see saying what is duplication means that we are saying twice in more than different ways. For example, if you look back to the statement about the function requirement of the restaurant advisor system, you will see two statements. The first statement state system searches for suitable, and then system display matching. So these two statements are saying the same concept, except they are mentioned in two different ways. So we say we have duplication. So duplication means not high quality requirement. Also, if you look to food type, price range, neighborhood, sizes are actually not well defined. So that means it's inadequate requirements that are not clearly stated. So this is not clear requirement. If we have requirements that are not clear, definitely they are the requirements of low quality. And that means at the end, we will come up with a specification document of unclear requirements. So when we send it to the developers, they might be able to design it, but it might end up to have a product that is not actually what the customer wanted, because we started by unclear requirements, which ends up with a poor design or even not related to design. Also, if you go back to the set of functional requirements, you will see a lot of ambiguity. For example, we see the statement talking about reservation databases and automated reservation system. So are they the same thing or different? So we don't know. It was not clearly stated. So this is ambiguity. So that means we do have undefined requirements, which also will cause deficiency in the quality. Unclear statement again, it appears that some listed restaurants are not in the reservation system or databases. What does the system do with the restaurants that are not participating? If there's any action to be done, are they omitted from the list? Or you could later add them, or you would like to refine them? That's not clear. So your requirements are not well defined. So this is unclear requirement statement. So that's another deficiency in the quality of the requirement. Unspecified requirement means that um, there's something that was not actually specified. An example is we could ask a question like, can users select just one more option, or they can select more than one option for the type of food, or even for smoking arrangement? This was not specified. So that makes unspecified requirement. Incomplete requirements in the restaurant advisor system, as an example, if users select the word reserve or the option reserve, there must be some way for the system to record those identifying information about the user. In order for the restaurant know who made it, this is omitted. We didn't see this actually in the statement. We didn't see this in the requirements. So this is incomplete requirements. All of these will show you that we might have deficiency in the quality of the requirements that might end up of um, poor design of a prototype of a software at the end, or unacceptable software, or a software that doesn't meet the need of the users because the requirements itself was not either well defined, was unclear, was unspecified, was incomplete. There's a lot of duplications. There's a lot of ambiguity or like incompleteness. All of these will contribute to the quality of the requirements that might end up to poor design and at the end not suitable software to be developed. Let's look to another example for Amazon system requirements. And let's try together to identify some functional and non-functional requirements, because now so far we talked about different type of requirements. Let's take a real example and try to come up with identification of both the functional and non-functional requirements. If you go and visit the amazon.ca, you will see some functional requirements that would include search option. So the website provides search, which enable user to find items. This is mainly based on a variety of item characteristics. We will also see a browse option, which enable user to look through items. We, of course, see a shop option, which enable users to select and purchase items. And finally, we have the comment options, which enable users to provide the feedback on items. And also it provides you with the capability of reading other users' comment on items, so customer reviews. All of these are related to the functionality of what the website will provide. So these are functional requirements. If we are looking into non-functional requirements, we are for Amazon website, the system should work on any web browser. This is mainly the operational non-functional requirement of the website. The system should be available 24/7. This is a performance requirement. The system enabled registered customers to review their own accounts. This is security requirement. So this is another non-functional requirement. And the system exists in versions tailored to global users. Like you could have system in French or even Japanese, German, or different language. This is culture requirements. So we can see operational requirements, performance requirements, security requirements, and culture requirements. All of these are examples of non-functional requirements. So you look to the website of amazon.ca, you see some buttons that or like features that allow you to browse, to search, to browse into the system. And then all of these tasks are aligned with a huge set of non-functional requirements. After we talked about requirements, the requirement engineering process, different activities of requirement engineering, including inception, elicitation, analysis, specification, validation, and then documentations. I would like to go over some fundamentals concepts related to modeling. So what we can see is when we gather requirements and we collect those requirements, and then we went through this requirement development process. We started by some questionnaires or even interviewing the users to collect functional requirements. And then we review some existing documentations and observe the business procedure. And then we even provide some research vendor solutions in which we are able to understand the new system constraint, understand the new system procedure, understand the new system functionality. It ends up that we are developing the requirements and the models. The models for the requirements and for the new system. So requirements and modeling, they actually go together. We in the field of software engineering, we use the notion of system engineering sandwich. What is the system engineering sandwich? is we have layered, multi-layers of requirements in modeling, requirements and modeling, requirements and modeling, requirements and model, and so on. So you do have requirements and then you do model to the requirements. You do have requirements and then you perform model to the requirements, mainly for functional requirements. So they build on the top of each other based on the tasks and subtasks involved in the project. But at the end of the story, we need to understand why we combine actually requirement engineering on the concept that we have multiple activities involved with modeling at the end. For example, in the analysis phase, we know that models, they help to understand the problem domain. For the documentation phase, those models can be used for describing the requirements, and instead of just using the natural language. So when you have models for documentations or like use cases as an example, those use cases can be easily used to describe the requirements instead of just using your natural language. Keep in mind that requirements are always in a textual format, just text. Thus, there is a chance of high ambiguity or even misunderstanding between all type of stakeholders of different background and different terminology. So modeling, in particular graphical modeling, is a good visual way of understanding those requirements, provide unification of the representation for the stakeholders who have different or variant culture, even language. In this course, we will focus on different modeling technique along the way in either elicitation or analysis or specification. In each of those activities or phases, there are many different techniques that can be used for modeling, in particular for functional requirements. We will talk about them in different lectures. Let's define some terminology related to models and modeling. What is a model? It's just a simple representation of some aspect of the system that will be built. Different type of models that we prefer to use it to model requirements at the end, including textual model, graphical models, and mathematical model. A textual model is just like something that is written or described, and this is the common SRS. We use graphical models like diagrams and schematic diagrams or sequence diagrams. In general, we have visual modeling or graphical modeling. This is mainly related, like an example, to the UML diagrams. Or could we even have mathematical models like formulas, statistics, and algorithms that could be used to model the requirement mathematically? The most common ones are textual and graphical. In the course, we will talk about the SRS in details, as well as different UML techniques that are used for graphical modeling of the requirements. Now, we are talking about modeling using visualization to the requirements to provide better analysis and better specification. There are two approaches for system development or modeling. We could have structured approach or object-oriented approach. Whether you're going to model the system using texture model or you're going to use even graphical model, you have to be careful about, are you going to use a structured approach for the modeling or you're going to use object-oriented approach for the modeling? Structured approach comes with the concept or the notion that we describe a system as a set of processes and data stores. Processes would accept input and just produce output. It's a very simple approach to deal with requirements modeling. It was very, when people started to model requirements, they started by the structured approach. So they started this one first, and then they figure out some drawbacks of the structure approach. So they moved to the object-oriented approach, in which we view system as a collection of interacting objects, like object-oriented, and those objects are interacting together to achieve a certain task. We allow objects to send and even to respond to messages. We provide encapsulation, so we provide modularity, mainly like the UML diagrams, structured format like the DVDs, for example, DVD diagrams. People, they started by the structure approach of modeling, and then they moved to the object-oriented approach in some software systems. Recently, some people they actually still using structure approach for modeling requirements. Most of the systems they use object-oriented approach, but we still have some systems that use a structural approach for modeling requirements by simply just defining a system as processes and data stores, and processes are interacting with some data storage. In the structure system analysis, like if you look to the system in a structured way, and now you provide a modeling paradigm for the requirements, but in a structured way, we are talking about environmental model that later on will be a behavior model. So what is an environmental model? Is the model that actually defines the scope of the proposed system, in which we define the boundary and interaction between the system and the outside world. The environmental model could be easily described using statement of purpose. We could use context diagrams and event list. And then if the environmental model is later transferred to the behavior model, both of them are structured. We just have processes and data storage. In the behavior model, we are talking about modeling of the interior behavior and data entity of the system. We are modeling the functionality, the functional requirements, and example of behavior models in a structured system analysis modeling, including data dictionary, data flow diagrams, entity relation diagrams, entity relationship diagrams. So in this course, we will talk about context diagrams. We will talk a lot about data flow diagrams, entity relationship diagrams, just to cover the structure system analysis. If we are about to address modeling, but using graphical approaches, using a unified model language like the UMLs, there's a lot of modeling techniques that could be used either on the analysis phase or the specification phase, or even on the testing phase, including but not limited to use cases, class diagrams, sequence diagrams, activity diagrams, state diagrams, package diagrams, and we're going to talk about all of these in class. So, summary of what I have discussed today, including the definition and importance of requirements. What are the main requirements engineering activity, including inception and then elicitation, followed by analysis, specification, and the verification, and then management. What are the different type of requirements, including business requirements, user requirements, functional versus non-functional requirements. How would you say that the requirement is of high quality or poor quality? This is the requirement quality. We also talked about different business examples as well as modeling techniques, whether those modeling techniques are using the notion of structured system analysis or using object-oriented concepts. Next class, we will start our first phase of requirement, inception, and elicitation, along with the aligned modeling techniques that are commonly used for elicitations process or activity in the requirement engineering full process. Thank you for listening, and I'll see you next week.